today's session. So it's one of our sort of classic antibody identification sessions. We often cover sort of red cell serology and some of the basic lab, the fundamental lab work that we do. And today we're going to be exploring a case study that highlights some of the challenges of providing blood for patients with blood group antibodies. And this involves a real case that we received into the NHS BT RCI laboratory for a patient with multiple antibodies. And today we're joined by Helen Thom. Helen's a registered biomedical scientist, and she's currently working with NHS Blood and Transplant as the red cell immunohaematology development lead, coming from years and years of experience working in NHS BT's RCI lab. So very, very knowledgeable. It's actually Helen's eighth, correct me if I'm wrong, Helen, eighth time leading a session today. Always very popular. Always really good feedback on these sessions. So I think we're gonna have another really interesting session today. So without further ado, I'm going to pass over to our speaker today, Helen Thom.
Well, thank you very much. Thank you for having us back. I do enjoy coming and sharing these talks. And for those of you who haven't seen me talks before, I'm quite passionate about antibodies, and I'm a little bit sad as well. So I normally like to ask daft questions. Feel free to pop anything in the chat as we go along, and I just hope that you enjoy the talk today. So we'll just make a start. So the outline of today's session, we're going to just cover a historical case that came into the lab when I worked in Jka-se RCI, and we're going to talk about a few things that you sort of need just a little bit of background. I'm not going to do how to do an antibody ID in this one, but it is just some of the background information on some of the tests that would perform in order to get the results that we have for this patient. So we're covering IAT, direct agglutination, direct antiglobulin test, phenotype versus genotype, what an eluate is, and then finding blood for the patient and how we'll go about doing that. So firstly, I'll just jump straight in. So what makes an antibody clinically significant? There's various guidelines you can go in for this. You know, you've got your sort of the Bible is the transfusion, the BSH transfusion guidelines, but the other places you can find things like this, such as the antigen facts book and your SOPs. But the ISBT definition is one clinically significant antibody can be defined as one capable of causing accelerated destruction of a significant proportion of transfused cells, blah, 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 or causing HDFN. So essentially, it's something that can destroy your red cells and cause you problems. So then I was just thinking about this. Well, are autoantibodies clinically significant? A lot of the time you can go in, again, you can go in your BSH guidelines here, but a lot of the time, autoantibodies, I would just say that they're a pain because they can mask if there's any underlying alloantibodies. It can interfere with your routine testing. So sometimes if you've got a patient who has autoantibodies, you would have to refer it to the reference lab. One thing you need to think about in terms of your autoantibodies is a lot of them are just mimicking. So autoantibodies, you might have something that mimics an anti-D, or it might mimic an anti-little e or something like that. And it can just be a bit of a pain when you're trying to cross-match. But if you look at your guidelines, one of the things that they say is if you do have an autoantibody, you really need to look at your sort of phenotype for your patient, because one of the things that we don't want to do is give antigen negative blood for an autoantibody that would cause your patient to be sensitized, and you would actually cause them to produce an alloantibody. So prevention of the development of alloantibodies is usually of more importance. These are things just to bear in mind as we go through the talk. So one of the tests that we're talking about, so when we do antibody IDs, we use an indirect antiglobulin test. And when we're doing this, we're looking for IgG antibodies. And IgG can't bridge the gap between the red cells. So one of the things that we use in an IAT test is a bridging antibody. This is the time bridge. So I have used this previously, but I do like this little animation. So you just need something that's going to get those red cells together so that when you centrifuge your sample with your patient's plasma versus your donor red cells, you need something to cause agglutination so you can see when you've got a positive reaction. So if you didn't use this bridging antibody, you could centrifuge it forever and you wouldn't actually get a positive reaction because you need something to help cause agglutination. And this is how your anti-IgG works. You can have monospecific anti-IgG, but what you generally tend to find is we use AHG, which is your anti-human globulin, and that's the green. Either you can have it as green liquid in a bottle, or it's already impregnated into your cards. And we use this, so I've mentioned this, we use this for antibody ID, but you can also use it for when you're phenotyping your patient using IgG anti-sera. So that's your patient's red cells against known anti-sera. So then we've got direct agglutination. So this time, because IgM's massive. So I remember this when I was at uni, I used to think IgM's massive. It can just get a hold of the red cells, centrifuge them, and it can cause agglutination. No problem. You don't need AHG for this. And this is typically what we use for blood grouping when you're doing your ABO. And we're going to use it for when we're phenotyping. So you can use it for your reagents where you use direct agglutination. There's no AHG involved in them, and it's useful for detecting any cold antibodies that you've got going on. So then we'll have the direct antiglobulin test. So this is almost sort of a mix of the two of them, really, because what your DAT shows you is what is bound to your patient's red cells. So when you do this test, it's a drop of your patient's red cells, but you want to know that if your patient's been sensitized at all, so has it got any antibodies bound to the red cells? So you can see there, you've got IgG positive down at the bottom. We'll normally perform this test when we've done when we've had a positive autocontrol. So that's when the patient's own red cells and the patient's plasma have been mixed together in an IAT, and you get a positive result. That's telling you there's something going on there. So if they're recently transfused, you've just got to bear in mind that it's a mixture of your patient and donor red cells. So what you can sometimes see when you perform this test, you might actually get dual population, because it would be negative because they might, if they're not bound with IgG, but any sensitized donor red cells are going to be bound with antibody, and that'll give you a positive result. And this is really useful because what we can do is if your patient's been transfused and we know that they're positive for IgG, it's telling you that there's something bound to those red cells, but we can actually elute these from the red cells in the blood sample and find out if there's what antibody it is that's bound to those. But just a little sort of disclaimer at the bottom there, interpretation of positive DATs must include the patient's history, clinical data, and results of other laboratory tests. So it's part of sort of many things that we'll look at when we're doing the tests on these patients. So another thing I want to cover with you today is sort of pheno versus geno. So phenotyping, we use these to determine what red cell antigens are on the patient's red cell. And it shows what's actually expressed. So if you're testing the patient's red cells, if you mix it with your anti-sera, you're going to get a positive or a negative result. If it's positive, it shows that the antigen is present. If it's negative, it shows that the antigen isn't present. So it's really useful when we're selecting blood for your patients to know what the phenotype is. So if they found an antibody, you want to see whether it's an autoantibody or an alloantibody and give appropriately matched blood where required. You can't perform this when a patient's been recently transfused because there's two populations of cells. So you'd have your patient's red cells and your donor red cells. You wouldn't know which one was which, and you could get a false positive reaction that way, or you could get a false negative reaction even. And bear in mind as well, if your patient has an IgG positive DAT and you use an anti-IgG anti-sera, that can actually interfere with the results as well. So you would get a false positive result if your patient was that positive, even if they hadn't been transfused. So what you can do instead is you can perform a genotype. So if your patient's been transfused and or has a positive IgG DAT, you can extract the patient's DNA from the white cells within the blood sample. And the reason that this works is even if the patient's been transfused, because the red cells, the donated red cells are leukodepleted, basically gets rid of the majority of the white cells there. So you know that any white cells you're extracting the plasma, any white cells you're extracting the DNA from can only have come from the patient. Now this shows what genes are present, but they might not be expressed on the red cell. So what we'll call this is a predicted phenotype because it's the antigens that are likely to be on the red cells based on the genes that they have. But there's various mutations and things that could cause the antigen not to be inserted into the red cell. So that's why it's a predicted phenotype. And we can perform it following transfusion and when the DAT's positive because we've got no anti-sera to interfere. So I'm just going to give you a quick little talk on acid elution or eluates or elution, however you want to call them. And I'm aware some labs may perform these already, but I know there's quite a few labs don't actually perform eluates. So we've got red cells, and you can see there they've been sensitized with IgG. So we've got what IgG positive DAT. It's telling me what's going on in the patient in vivo. If your patient's been recently transfused, like I said before, we can actually take these antibodies that are bound to the red cells. They might not be free in the plasma. And we know the patient's been sensitized. We can actually take those off the red cells, test them, and see if there's anything underlying. So it's really important when you perform an eluate that you've got to wash your red cells. You're not putting them in a little bath, you're just sort of mixing them with wash solution or saline. And the reason that we do this is because you don't want any unbound antibody to interfere with your testing. It could neutralize your antibodies that are there, give you sort of false negatives and things. But you actually want to see what's bound, so you just need to wash off the plasma because it's the red cells that you're interested in this case. So we generally tend to perform these when the patient's been transfused within a month, in the last month. We can do them when there's been a reduction in the transfusion interval. So if you've got a patient who only gets transfused once a month, then all of a sudden they're coming in every week, you might start thinking, well, I best do an eluate because there could be something underlying there. Or we're going to do it when we've got an increase in the strength in DAT. So if you see a patient, the same patient comes in once a month and they've always got a DAT of 1 plus IgG. If all of a sudden you'd do an eluate every now and again, but you wouldn't need to test it every time. But if that patient then comes in and it's 2 plus or 3 plus, there's been a change, so you might want to do an eluate. Once you've done the eluate, you perform your antibody ID, and it just allows you to see what sort of stuck to your red cells, really. And I've just got a few little images here, and this is me performing an eluate years ago that I just took some pictures, just so you can try and see what's actually going on, because if you don't perform them, you might not know. And I'm talking about washing red cells and stuff, you might just think I'm a bit mad. So hopefully it's not too small on the screen there. So you take a ml of your packed patient red cells from your sample, but even though you might have taken the plasma off this already, there could just be some left over. So what you do is fill it up with wash solution or saline, give it a few washes. So in terms of washing in this sense, you rinse it, you'll put the ml of red cells in, put the wash solution in, give it a mix, centrifuge it, take off the supernatant, and then keep your red cells and keep that, repeat that process about 4 times, I think it was, when I used to work at the lab. And you're just getting rid of anything sort of that you don't want to be testing at that time. So you end up with this. So you'd end up with a ml of packed red cells that have been washed and get rid of your supernatant. So we might be familiar with these. This is what we used in the lab. So this is a kit called EluKit, and it's an elution solution. I'll try and say that properly. And what it is, it's acid. It's an acidic solution, and it encourages the antibodies to come off that are bound to the red cell to come off. So what you do is you take your packed red cells, and for every ml of red cells, you add a ml of this eluting solution. Can't say that. And you centrifuge that, and what you end up with is here is a supernatant. This time you don't want to get rid of your supernatant, you want to keep it, because what you've done is you've taken all the antibodies off the red cell. They're now in here. So you take that and you put it into a separate pot or tube. With this though, because it's acidic, if you tested it now, it would just lyse your red cells. So you have to add a buffering solution. So hopefully you can see here that there is some blue solution in the tube, and you just add this and it neutralizes it. So then when you are testing your red cells, so when you eventually just get around to perform your antibody ID, it's neutralized and you just treat it like you would plasma. But the difference is it's not the antibodies that are in the plasma, it's just the antibodies that you've taken off the red cell. Sorry, I can just see something in the chat there. I'll just have a... What reagent is in the side of the IgM? Why do we use IgM for anti-Sera? So, that's gone on the next slide there. With the cards, the one that I was showing you there, there's different reagents impregnated into the card. So in the same way that you would have IgG impregnated in the card to see if there's any IgG bound to the red cells, you can do a sort of extended a differential data they're called. So you can look for IgM or it would be C3d, C3b, just to tell you what else is stuck to the patient's red cells. So instead of just IgG, you can look for IgM if you wanted to. I hope that makes sense. Why do we use anti-IgG sera instead of IgM anti-sera? A lot of it's just down to the reagents and the type of antibody that you're looking for. So if it's generally tends to be an IgM antibody, you can detect it using Ig anti-sera. But if it's an IgG antibody, you would generally just tend to use IgG anti-sera because that's just the way that you've got it detected. I'm sure there's a much better explanation than that. So if everyone's okay there, I will just move along. We're just moving on to the case now. So this one, it's a few years old now, although I remember it vividly, which hopefully you'll understand why at the end of the talk. So we had an 85-year-old male came in for investigation. So they wanted antibody ID and 2 cross-match units. This was the first time we'd seen this patient before, but the patient was regularly transfused at their hospital for many years prior to us seeing them. The clinical details, so we got a diagnosis of anemia, which was always my favourite because, you know, anemia, what kind of anemia have they got? Hemoglobin of 70 and last transfused 2 months previously on the 19th of April. We've come in this time, they've got some historical details because obviously it's really useful to include your historical information on your request form. And they were told they were O-pos and big C-neg. This time they were DAT-pos, they weren't normally DAT-pos, and they had a positive antibody screen. So this patient's multi-transfused, never really had any antibodies before, but has now decided to make something. So we did an antibody ID, and I know previously I've gone through how to do antibody IDs and things, but just for terms of this case, I'm just going to show you what we've found in the patient sample this time. So the first antibody that we identified was an anti-big C. We were happy that it followed your BSH guidelines, that we've got 2 positive examples and 2 negative examples. We can confirm it, and the hospital told her the patient was big C neg, which was really handy. We also identified what looks like an anti-little e. So we're thinking, right, that could be an anti-little e. But one of those when you sort of scrutinise, the reason that I've said that we're thinking this is an anti-D is just if you look at the phenotype of the cells, the pattern of reactions that you're getting, it's slightly weaker, even though it is a big pan-reactive, it's slightly weaker on the little e negative line and the heterozygous line and things. That's just a sort of key. It's one of the things when you're doing your antibody ID, you look for the difference in gradient to see if there could be something there. And for those of you who's been to my talks before, I've got a weird sort of thing for kid antibodies. It's almost a bit of an obsession with kid antibodies. So I remember looking at this and going, oh, it looks a bit Jka-ish. And that is my official terminology, which I'm sure other people will use that as well. But I remember saying that at the time, like, oh, it looks a bit like a Jka, but I couldn't actually confirm if it was a Jka because we didn't have enough positive and negative examples in order to do that. The patient's DET, it required a DET because it has a positive auto, which would said previously, you know, if you've got testing that patient's plasma with their red cells, it's positive, you would do a DET. And the hospital had already told us, because we used the clinical information, that the patient had a positive DET. So what I did was I put some more cells up, confirmed, yeah, that anti-C is definitely there. Does look a bit like an anti-little e, but we don't know whether that's an autoantibody or an alloantibody. But it's definitely looking as though it is there. And I was just convinced, I mean, you can't, sorry, because it is small, but I just felt that there was an anti-Jka there, but it wasn't conclusive. I didn't have 2 positive examples. I didn't have 2 negative examples. I just had a sniff of a Jka. And when you work in a reference lab, I think you do become a bit obsessed with them. So what we've got so far, we've identified an anti-big C, we've got an anti-little e, and a possible anti-Jka. So then this raises a question, are the alloantibodies, are the autoantibodies, are they clinically significant, are they not clinically significant? What's the phenotype? Can we do a phenotype? The patient's got a positive autocontrol, so we do need to do a TET. In terms of an eluate, the patient hasn't been transfused in the last month, but they have made antibodies, and I would be inclined to go, yeah, I'm probably going to perform an eluate on this patient. But going back to the phenotype and asking if these are clinically significant, we know what the patient's historical phenotype is. So the big C neg at the hospital, the O-pos. We've identified them as O-pos, big C neg, and little e positive. They're also little c pos, big E pos, and big K pos. We've decided to do a Jka and B phenotype on this patient because we want to see whether the antibody's there. Well, we can't see whether the antibody's there, but we want to see what the patient's phenotype is. We can use them because these are all sorry, my brain's just stopped there. Because these are IgM anti-sera, we won't get any interference from the positive IgG DAT, so we can perform phenotyping, but what you've got to be mindful of is the patient was transfused 2 months ago. And what we would generally say is if the patient's been transfused in the last 3 months, then you shouldn't really be doing phenotyping on them. But one of the things we did ring up and ask the hospital was, how many units has this patient been transfused? If this patient had like 20 units in the last month, there is no way on this earth would be performing phenotyping on them. But actually they've been transfused 1 unit. So you were kind of like, we'll match what the hospital said they've got. There's a good chance that this is what the patient's phenotype is. So that's what we went with. So in terms of the significance, they've made an allo-anti-big C. If you went to your antigen fact book or wherever else you would get that information from, it's clinically significant. And once you've made an RH antibody, you've got to give fully matched RH blood for that patient. But this patient's actually positive for all the other antigens, but if they were negative for any, would give additional matched blood. And you've got to give them antigen negative matched for the big C as well. So because it's an auto little e, you could argue with this patient that you could get away with giving them big C neg, little e neg blood. But what you don't want to do is waste units. So you wouldn't want to give them R2, R2s because only about 3% of the population are R2, R2s. And you don't want to waste blood on someone who doesn't really need it. Yes, it might be a pain cross-matching, but actually it was an enzyme-only auto little e, and it's an auto antibody, which is unlikely to be clinically significant. So I would just give big C neg blood in this case. We've got a possible allo-anti-Jka there. So Jka, also Helen's favourite antibody at the bottom. You might notice that. That's probably the most important thing you will learn from this today. These are really significant antibodies, your kid antibodies, and they can disappear. So you might have a really strong example one time or a really weak example and then never see that again. So if you didn't test that patient in between being transfused, you might miss the opportunity. So they're actually a cause of significant delayed of transfusion reactions. And you've got to give antigen negative blood. Now in this patient, we're not saying that it's definitely there, but if you even have such of a sniff of anti-Jka and the patient seems to be Jka neg, you'd be given blood. So I'm just going to do a poll now, and this is just for my own sadness, but I'm just going to launch it. And if you just want to type in the word cloud, what your favourite antibody is. If you can't do it in the chat though, if you can't do it on polls, just stick something in the chat if you want. I'll just give you a minute to have a look at that. You don't have to fill it in. Like I said, this is for nobody's interest but my own. So hopefully this will work. And whatever the biggest word, when we've done this, the biggest word is the most popular one. Oh, that's a good one. I'm going to imagine that the anti-PP1PK is from a reference person. WRA, I like that. Your free dog Brock. Ooh, Chido. Oh, I forgot about Chido. I like a good Chido. They just, it's a shame these aren't in person because we could probably have a very long discussion about whose favourite antibodies. Anti-M's winning there, I have to say. I'm slightly disappointed with that. Oh, it's gone now. Can't see any other JKs in there. There's no one feeling the love for the kid antibodies on the call today. No. Fun anti-G. Duffy 3. Nice. Oh, it's looking good. Looking good. Well, thank you very much for that. Oh, I'm just gonna, oh, is it still happening? It keeps going up. Thanks everyone. Like I said, this is purely just for my sadness, and I will have a look at these later on. And that's good. Thanks for taking part. I'm going to close that there and just crack on with the talk. But thank you very much. Oh, someone likes a kid. Yay. So with this patient, like I said, what we ended up doing was decided to perform an eluate on them. Even though it was beyond the sort of 1 month period, but they'd made potentially 3 antibodies. I just wanted to take a look. And Disappointingly, it was pan-reactive. I don't know whether that's disappointing or not, but nice uniform reactions. You know, the patient's got an autoantibody. It's no surprise really that there was a pan-reactive antibody in the eluate. So with all the information that we've got there, we've said, you know, the big C is clinically significant, and we'll put this information on the report. Little e is unlikely to be significant, but it might cause problems cross-matching. And we've just said, it really looks like a Jka, but we can't definitively say it's there. However, we would strongly recommend, and will have issued, OPOS, big C neg, Jka neg, and we'll give the patient an antibody card, but we only could put the anti-big C on because that was the only antibody that had been confirmed. So a month later, we'll see the patient again. It's a similar picture. We've got the allo-anti-big C. This time, you can see that the Jka, even though we've only got 2 really weak reactions by IAT, this was enough to convince me that there was an anti-Jka there. So we went with it this time. Well, is the auto little e there? Yeah, it might be, but we can't really see because the Jka sort of makes it pan-reactive, and we don't. Because it wasn't coming, the Jka wasn't coming through by IAT on that line. We didn't have any patternized R2 cells, but so we didn't see whether the little e was there. This time there's been a change in strength for the DAT. So if this patient had came in and there'd been no change in the serology, no change in strength in DAT, probably wouldn't have done an eluate, but we did do one because there was an increase in the strength. And again, it was pan-reactive. Nice uniform reactions, which I said was pan-reactive. So this one, quite straightforward. We've seen them before. Happy we've got all that information, but the difference with this one is we've said that the anti-Jka was there. So we've issued a card to the patient to make sure that they're getting antigen negative blood if they need it. So saw them again in August, and I was like, oh, there's this patient at the back. This time, serology seems to be clearing up a bit. There's nothing going on by IAT, and we've got an enzyme only allo-anti-big C, and the Jka is there by enzyme only, and that anti-little e seems to have disappeared. Nice, pretty straightforward. The DAT was 2+, which was the same strength as the last time. So there's no change in the patient's serology, so we didn't perform an eluate on this sample. So report went out, basically pretty much the same as the last time. The only difference is we didn't perform an eluate this time. So the patient came back in October, and I remember this shift vividly. It was a late shift. I was on call. You're always on call when these things happen. So all we've got this time is an enzyme-only anti-big C. The KID antibody that we've previously reported, remember how I said they disappeared? So that crafty kid, I can see someone's written crafty kids in their thing there, so I'm going to steal that because I do like that. That's disappeared because that's what they tend to do. So it's nice in the fact that it fits with what you've said. But this time there's a DAT and it's 3+, so that's an increase. So there hasn't been a decrease in the patient's transfusion interval, but there has been an increase in the strength of the DAT. So I performed an eluate, which is what you would do following your protocol. So this is my eluate. So before I click onto the next thing, if you just have a little squint at the screen there and see if there's anything that you think that this might be. You can just I'm not launching a question for this, but if anyone wants to pop anything in the chat, that would be okay. I'll just give you another second if anyone wants to have a little squeeze and have a look. Yep, Nick's got it, little K. And I kind of went, uh-oh, anti-little K. That looks very much like a little anti-K. And I'm not going to lie, because I did just think it was going to be that uniform 3+ pan-reactive again. So now I'm going to launch a poll, and I'm going to ask you what we do next. Hopefully that will launch now. Like I said, if you can't access the poll, just pop something in the chat. So you can pick more than one answer for this one. So what did I do next? Did I confirm or exclude the presence of anti-little K? Did I confirm or exclude the presence of other antibodies? Did I do nothing because I'm good to go, all sorted? Never mind that you were really smug that you thought it was just going to be a pan-reactive eluate. Or did I cry? It could have been any of those answers. You can pick more than one if you want. Hopefully people can, I can't see any results. Oh no, view results, that'll help. Well, there you go. Yep, so far we've got a lot of people saying confirm the presence of anti-K, confirm the presence of or exclude other antibodies, and cry. That's quite a good response. And I'm going to go on to the next page now. So yes, so those 3 answers. So nobody said nothing, you're good to go, which is good. I did need to confirm or exclude the presence of anti-K, because it could have just been that it was that pan-reactive antibody, just, you know, not necessarily being pan-reactive, might have just had a few wishy-washy reactions. I also would need to exclude any other antibodies that are lurking around using little k negative cells, which would be difficult because that's a high incidence antibody. So 90% of your cells are going to be little k pos. Crying's optional, but was the most likely outcome. There might have been a few tears when I realised how much of a pain it was going to be to try and get blood for this patient. So what I did was, it's exactly what you've all said there. I needed to confirm the presence of anti-K. So this is me first panel. So originally I just did 1 to 6 because I was like, it's going to be pan-reactive. It was my own fault for being smug. I put up the rest of the panel just to confirm, and it sealed the fate for me. But I still needed to get a positive, 2 positives, 2 negatives to confirm the antibody, and I also needed to exclude the presence of additional antibodies as well, bearing in mind that this patient is clearly a responder. This was now the 3rd alloantibody. So I put up another panel. Yep, it's definitely there. And at this point I was just going like, oh my god, what am I going to do? I just had a few other cells, because the good thing is with the reference lab we've got lots of cells that are available. So these are just a demonstration of some of the cells that I did put up. I didn't keep doing full panels on everything. We also have a rare cell panel that we can use as well. And I know that the patient's other antibodies were enzyme only, so I wouldn't get any interference from them, because sometimes when you've got multiple alloantibodies, it's difficult to get your exclusion when they're all there by IAT. But fortunately with this, because they weren't masking anything else either. So I was able to confirm whether that anti-K was there. So is this antibody clinically significant? It's an antibody to a high incidence antigen, like I've mentioned. It is clinically significant, so if you went in your antigen facts book or other available sources, you've got to give antigen negative red cells for this. Transfusion reactions can be mild to moderate or delayed. I always love the sort of definitions. It's basically like, it can be nothing or it can be really bad. So you're just like, not going to want to take the chance. I need to give antigen negative blood to this patient. In terms of HDFN, that's another one where it can be mild to severe. Nice to know. The patient's phenotype. So I'm going to launch another poll now. Can we phenotype this patient? Hopefully this will work. And again, if you can't use it, just pop it in the chat. So can we phenotype the patient? And again, you can select multiple answers for this. So yes, you can phenotype the patient. No, you can't phenotype the patient because they've been recently transfused. And you can't phenotype the patient because they are IgG DEAT positive. So I will just see how we'll go with that and just give you a minute or so to go over it. Yeah, so I've got a few different answers coming in there. So there's a few people have said you can phenotype the patient. 66% have said you can't phenotype them because they're recently transfused, and 28% have said that you can't phenotype them because they're IgG DEAT positive. So for this one, when we have a look, we know that the patient is big K positive, but we don't know what the little k status is. We know that they're historically Jk neg B pos. Little k anti-sera is IgG anti-sera. Now I wouldn't expect everyone to know that because people don't know these things off the top of their head, but it is. So you can't phenotype them because the DAT's positive, but you also can't phenotype them because they've been recently transfused and there's a dual population of cells there. And the chances are they'll have been transfused K-neg blood, or heterozygous, a mix of sort of K-pos and little K positive blood, so you wouldn't be able to see what was going on there. So we can't phenotype them, but we can perform a genotype, because if you remember, it doesn't matter if the DAT's pos or the patient's been transfused in order to do a genotype, because we use the patient red white cells. So moving on from there, so I'm going to ask you another question in a moment. So this bag of blood on the picture on the right hand side is actually the unit that I was busy cross-matching for this patient. So as well as doing the antibody ID, and before I'd set up my eluate, I'd cross-match 2 units for this patient. So you can see there it's O-pos, big C neg, Jka neg, and this unit's not K negative, even though 90% of your units will be K negative. And the reason is for this, when I was selecting blood, I know the patient's K positive, so I was trying to conserve my K negative stock. So I was giving this patient K positive blood, not thinking about a Cellano, because if you see this little table here, the chances of anybody being little K negative in the donor population is 0.2%. So I was, no, it's not a bad thing that I'm giving this K positive patient K positive blood, because there's a good chance that, you know, out of that it's going to be heterozygous. So what are the chances of finding blood for this patient? So what you need to think about is, when I ask this question, if you were to walk into the fridge in the blood bank and say, I want some blood for this patient, but none of it had a label on, and you just had to go and randomly test units yourself, so you didn't even know the blood group, how many do you think? And that's, so at NHSBT, you know, we've got the blood group on the bags, we've got the phenotyping on the bags. What are the chances that you, when you walk into your fridge, how likely is it that you were going to get this? So what we have here, how likely is it if you just walked in and just randomly selected a unit, how many would you have to get in order, how many would you have to test in order to get blood? So would it be 1 in 100, 1 in 1,000, 1 in 10,000, 1 in 20,000, or 1 in 200,000? I'll just view the results and see what people think. There's quite a few there. We've got quite a few on the 1 in 200,000. It's changing. I'll just give that another few seconds. There it goes. Lovely. So far we've got 5% have said 1 in 100, 20% have said 1 in 1,000, 21% said 1 in 10,000, 16% 1 in 20,000, and 34%, so quite a large number, have said 1 in 200,000. You would think that it's that, but the good thing is with little k, it doesn't seem to be too bad. So what you've got to do here is you can do your frequency calculations. I don't know if anyone's done the BBTS specialist certificate in transfusion science practice, but that's one of the things it teaches you how to do these, is how many units you would have to test and how you would know. So you've got to do sort of like your calculations on your antigen frequency. So we know that the patient's group O, which are around 45% of your donor population, the frequency of the big C antigen is 68%. So 68% of people will have the big C antigen, 76% of people will have the Jka antigen, and 9% of people will have the little k antigen. And you think, oh, well, that's good, because in there you've got your heterozygotes, so that'll be people who are big K positive, little k positive, which is where they're sort of, and you've got those 0.2% who are little k, little k. So in terms of the antigen negative frequencies, your big C neg is 32%, your Jka neg is 24%, and your little k is 0.2%. So if you didn't know the blood group of the patient, you would have to test around 22,000 units in order to get it. So that would be the 20% of people who've said it's 1 in 20,000. You're right, because you'd have to test roughly that many. The good thing is, because we know the group O, you sort of narrow it down straight away. So you've essentially halved how many people you would need to test. So that would be 13,000. So if you went for 1 in 10,000 or 1 in 20,000, I would say that you're both right there. Fortunately, what we have is a system called Pulse. So when you donate blood, that donation, it's wandered into our system. It's followed at every step of the way and this is, you know, when we're going on about audit trails and things like that, you know, this donation history from the start to the very end. And what we can do is look on our computer system. So what I decided to do was scan in the unit for this patient, the one I'd already cross-matched, and I'd got a compatible cross-match for this patient with this unit as well. But I looked just to see what are the chances of this being little k negative. Is it going to be 1 in 10,000? Is it going to be 1 in 20,000? Or is it going to be the cross-match compatible unit that I've got in the fridge already cross-matched for this patient? Unfortunately, I wasn't that lucky. So if you see the purple circle there, where we've got the big K, it's positive. When we perform phenotyping on all of our units in the donor testing department, we do it, when we've done it twice, you get a positive or a negative. So this has been confirmed twice. We have tested it once, but it was little k positive. So we haven't tested that again, because once we know it's positive, we don't really need to know that it's negative. So unfortunately, this unit was heterozygous. It was compatible for the patient, but that's because the Cellano wasn't coming through by IAT. It was only there in the eluate, so that would be why. So unfortunately, I had to order some different blood for this patient. And rather than having to test 20,000 units or 10,000 units, I just went onto our system. So this screenshot here it's not the current search for this sample that I did, but this was a search that I did later on for this patient. So I can type into the computer what I want. So I typed into Pulse that I wanted O-pos, big C neg, Jka-se neg, Cellano neg. There was 4 units in the country. So that's not bad going really. So the patient didn't have to wait to be transfused. With this patient, they wanted the blood for the next day. So we're able, there's different codes on here as well. So like we'll know what the internal location codes mean, and these were both in London. This patient was in Newcastle, so I got in touch with hospital services and I just said, can you order me 2 of these units to come up overnight on one of our runs, so I can get the blood to this patient in the morning. So the blood was there when we came in the next day, cross-matched it and sent it off for that patient. So these were the results on that day. So it was a nice phone call to the hospital going, we're not going to send the blood out tonight, but it will be with you tomorrow. And they just, you know, enzyme only anti-big C, previously reported anti-Jka, because even if it can't detect on the current sample, we do report previous clinically significant antibodies. We said that was 3+ in strength. We didn't evaluate and we found anti-little k. There was also a pan-enzyme antibody in there, which I got a bit distracted with telling you about the little k. So we ordered the units. Like I said, we got them up from London, issued them and sent an updated card for the patient. Because we couldn't do the phenotyping because of the POS DAT and the fact that we're transfused, we asked the hospital for a sample to do a genotype just to confirm that it was an alloantibody, and it was confirmed that it was. And it also confirmed all the other phenotyping for it, which was great. So what about the patient? Because, you know, we do lots of antibody IDs and things, but for us it was, how is this going to impact this person's life? You know, we could have difficulty getting the blood for this patient. So the anemia turned out to be myelodysplastic syndrome, but the consultant said the patient was fairly fit, came to clinic on the bus. They always seem to have a hemoglobin of 70, regardless of how many units he gave them. They had tried whatever this is, I'm not even going to try to pronounce it, and I don't work, because I don't work in hematology, I don't really understand this bit, so I'm not going to try. But basically they just wanted to give him a synthetic recombinant form of EPO to try and minimise the risk, well, minimise the chances of him needing a transfusion. But they said they'd previously tried it and it hadn't worked, but they were going to up the dose and see if it would help. They very kindly moved the clinic from a Monday, because they used to sort of try and either, you know, might have to send a sample on a Monday night. So they said that they'd move it to a Wednesday, so they got blood on a Wednesday. So I had a couple of days to try and find blood if we needed to. And they said they probably would be transfused every 2 or 3 weeks. We were seeing them once a month and they actually stuck with that. And just out of interest, this is our final poll. So why is it called? Why is it not letting me launch? Oh, it wasn't letting us launch. So why is anti-little k called anti-Cellano? So it's an antigram of anti-little k. It's an antigram of the first patient who it was found in's surname. it's an anagram of the person who discovered its surname, or it just sounds cool. I'll just give you a few minutes just to do that. Well, not a few minutes, a few seconds, because time goes very quickly in these things. Nobody selected that it's an anagram of Auntie Little K, but some people do think it's cool, so I'm glad to see that it's not just me, even if it's only 3% of you. So it's a toss-up, sort of. It's pretty much even between an anagram of the first patient or the discoverer and serologist name. Just to won't keep you in suspense any longer. It's from what I was told, and I could be wrong, but it was the patient's surname. So what they quite often used to do was things like Duffy and Kidd, when they found those antibodies, they named them after the patient. And in this case, the patient's surname was Nocella, but it didn't, because all the other antigens in that blood group were K or K sounding, they changed it to Cellano. So that's why we have our curious Jka-se of Nocella Cellano. And I just want to take a minute, so this is my final slide, but when we're doing things like this, like I said, we always think about the clinical side of things. And in terms of the clinical side, it's those who have direct contact with the patient. So to me, there's so many people that are involved in patient care across the NHS. So we're blood donors, without them, we would never have the blood for these patients anyway. We've got donor carers. We've got people within the blood service. We're manufacturing, testing, hospital services staff. We've got, like I said, the testing departments and things like that who are doing all these phenotyping on these patients, on the units. We've got logistics staff, hospital services staff who issue it and are a really big help to us when we have these rare requirements for blood and they're all across the country. All the coordination that goes into getting these moved around, it's a feat of engineering and it's great. So we've got transport, but you've got your couriers who come and collect the blood, send the samples across and things like that. Then we'll have yourselves, who are all the BMSs who are in the lab, the BMSs who are in RCI performing all of these tests. We've got everyone who works in a hospital, all your porters, your doctors, your nurses, all the clinical teams, basically every single person who has a hand in giving patients the care that we use. There's millions of them in all of this and everything that we do, and I know you still feel the same about me. There's a patient in the middle of it, and we do our jobs because we love them. So thank you very much, and I'll just go on to the last slide. So that's it from me, unless there's any questions. Thank you. Thanks.
Thanks so much, Helen. We've got one question there in the chat. So please, why did we conclude the anti-K is an allo antibody instead of auto?
So it's an allo antibody because the patient was negative for the Cellano antigen. So therefore it's an antibody that they've made against something that they are lacking. So it's an allo antibody. If the patient was little K positive, it would have been an auto antibody. But they're big K positive, but they're little K negative. So they're K negative, so it's an allo antibody because they're missing the antigen. Hope that helps, thanks. Someone's asking there if we'll keep little K neg units in the frozen blood bank. There will actually be units in the frozen blood bank that are little K negative, but I don't know how many we would keep. And with something like that, even though it's a high incidence antigen, you do get the odd one sort of floating around. I mean, this one, if you think they had to be big C negative, but they also had to be Jka negative as well, so it sort of decreased that. But yeah, we do actually get quite a few, but you could keep them, so if you wanted to, and there will be a stock of them. We have had it where we've had patients with multiple antibodies and rare antibodies that we've actually got in touch with the frozen blood bank and said, can you find some units and keep them for this patient, which they've done as well, which is really helpful of them.
Great. So I don't believe we've got any more questions in the chat. So just want to say thank you so much, Helen, for volunteering your time for yet another hugely engaging session. I mean, we can all tell from the chat and the polls, how much this has really piqued our interests. And yet again, your huge amounts of first-hand experience and heaps of knowledge that's key to the success of sessions like this. So I'll just give the usual reminders here from the BMSEDG team. Thank you to all of those that have tuned in today. There's no need to register again, as you'll be automatically receiving invitations for upcoming sessions. Make sure you subscribe to our YouTube channel. QR code is just there. So in case you're unable to attend any of our monthly calls, you'll get notified when the most recent recording's been uploaded and ready to view. As we mentioned earlier, please complete the evaluation form either by scanning the QR code there or following the link that's just been put in the chat. There's also a link that would have been sent along with your joining instructions. This will prompt certificates to be sent to those who have evaluated within 7 working days. So coming up next month, on Wednesday, the 28th of June at the usual time of 2 p.m. UK time, our very own Danny Gaskin is hosting a discussion with Mark Tarrant from the Hospital Liaison Committee for Jehovah's Witnesses, where they'll chat about Jehovah's Witnesses and blood transfusion. This session is an exception and will not be recorded, so especially important for you to tune in next month. Thank you again, everyone. Thank you, Helen, and we look forward to seeing you next month.
Thanks very much, everyone. Thanks for your time.